Hello, everyone. Thank you once again for joining me. My name is John Kayode Abusi. I am a product security engineer, and I always say that my job sits at the intersection of product security and software engineering. Today, I want to speak about software engineering in product security. Now, as I get deeper into my career and I work within engineering org, I realize that for you to be a successful product security engineer or architect, you must know what you need to know, within the engineering processes, principles, methodology, and how things should be done. So that is what informed this topic, and that is what informed this video. What the work actually look like when you find yourself in a function or a workflow that is purely software engineering. How do you handle stuff as a product security engineer or architect? What do you do? The job in one sentence. A product security engineer takes a product or a feature and answer a single question before it ships. Where could this go wrong? Note, where could this go wrong? And how have we built it so it can't? How can we build it so that it won't go wrong? This video is to tell the story of a walk through one real project, a multi-tenant API called Secure API Platform, and follow the exact path a security engineer should walk. Now, the point is this. How do you, as security engineer, what exactly is required of you in your software engineering workflow? You will be part of that organization, and there are expectations. There are things you need to do to make sure that you are able to deliver a very perfect developer experience. Now, how do you do that? Where could this go wrong? How did we build it so it can't? So the first thing I want to talk about is represent. Now the feature, represent your feature or your products in a data flow diagram. That is one thing you have to do when you find yourself within that particular environment, because you cannot secure what you cannot see. Now, that is the first thing you do. Represent the feature you are building or you are protecting or you are designing for. Represent it in a data flow diagram. The next thing you do is to identify the trust boundaries. Now, the lines where level of trust changes when information is flowing from one level to the other. Where does that change? Then the next thing is model the threats against those boundaries. Now, what you need to do is to model threats against those boundaries that the level of trust do change. Now, using stride. So that is the methodology I want to use here. Now, when you model your threat, then you record your findings. The threats you identify, the boundaries you identify, the mitigation you intend to do, and the status, whether it's something you want to accept, something you want to remediate, you have to make sure you include it, the status. Then the other thing you have to do is to let the findings now drive your secure design. Now, the very reason why this is very important is that before you begin to write code, one important thing you have to note is that the design must drive even the code you want to, the risk analysis, the threat modeling, the representation will help you to do a very successful threat analysis or intelligence or intel. Then that will drive your design. Now, if you look at the project I'm bringing in, that helps us to drive a design like the password hash we want to use, the JWT claim, the tenant check as output of this thinking, not arbitrary choices. Now, what that does is that it helps you to make some right choices from design and architectural point of view. Now, so when you do that, then you drive the design, then you prove it by testing it. So security is not a checkpoint that software passes at the end. It's a property the software is designed to have from the first diagram. And the product security engineer is the person who makes that property visible, decided, and proven. So this is what I want us to look at. Now, let's look at draw it before you analyze it. Now, if you look at these image, you will see that I have the data flow diagram for my secure API platform. You see that I have like 3 boundaries here. I have boundary 1, B1, I have B2, and I have B3. Now, at B1, what happened is that users are crossing to the middleware. They are crossing to where they will be authenticated. Now, for the fact that a user or a service is authenticated doesn't make it devoid of threat. So that shows that there is one aspect of that particular workflow that it has passed securely. But when it comes to the second layer, which is the B2, what happened is that at this point, it's touching on data at the other side. And you don't want to leave it to arbitrarily open it to all the data available there. So what you want to do is to make sure you lock it down to the scope of that data that user or that services you have access to. So the third one there is the secret, the keys, the certificate, whatever is used to secure this workflow. Where is it kept? So that is that. So if you look at that, you can see the diagram there that it represents what I said. And we can move to the next one. Now, when you represent this flow, okay, so we move to a trust boundary is where the level of trust changes, like I've explained. The B1, that is the first trust boundary, untrusted inputs arrived. Everything here must be authenticated, rate limited, and validated. Now at boundary 2, a logged in user is still not trusted to touch arbitrary object. Object level authorization lives here. So what you do as security engineer is that at that point, based on this example, you've authenticated, but the trust boundary 2 is where you begin to do object level authorization. Then the B3, service, then its secret. The signing key, the password hashes, defended by secure by default, config, and log redaction. That is another trust boundary that you need to protect. So now let's look at this. The stride. You draw the system, you draw the trust boundary, you walk stride per element, you record your findings, you decide the disposition. Now, what is stride? Stride is a threat modeling tool in software engineering. So S stands for spoofing, that is pretending to be someone else. So in your workflow, you want to be sure that your design doesn't allow for that you have a mechanism in place to make sure that you checkmate users or systems to actually prove that they are who they say they are. Then tampering is unauthorized modification. Now you have to have a security mechanism in place to make sure that users or even authenticated sessions cannot modify something that they should be able to modify. Repudiation, deny an action. You should have maybe a logging mechanism in place that makes sure that, okay, when you do something, it can be proven, it can be evidenced that you do it even later. So information disclosure, leaking of data, or leaking of data, yes. Denial of service, harming availability. Make sure you build your system in such a way that that system cannot be brought down abstractly or by bad actor. So you have to make sure that it's always available, whatever is happening. Then elevation of privileges, gaining unauthorized right. So at every trust boundary, you ensure that you design. When you begin to, before you design, you make sure that you run that boundary against these 6 security patterns and make sure that, if there is any boundary that is prone to some of these, the vulnerability of some of these, then you begin to design for that. How do we ensure that nobody can deny what they do? And that is what will make you say, there must be a logging mechanism in this application or at this particular endpoint. So I've explained, the basic concept about that. So let's look at the threat model. So let's look at spoofing, tampering, and repudiation. Now, token forgery is tampering. Replay to impersonate a user. Like, you got a token, you kind of maybe modify it or maybe to impersonate another user. Now that is tampering with the authentication mechanism so that you can pretend to be somebody else. So if you look at it now, it shows that it's spoofing. And repudiation is like you want to deny that somehow. So but what do we do here for my example is that JWTs are signature verified. That shows that you incorporate, in this example, I incorporated JWT into the workflow to make sure that when a token is tampered with, then that connection will be blocked or not allowed. So JWT is a signature verified, issuer and audience checked. So a token minted elsewhere can't be replayed somewhere else. So if a token is minted for a particular user, a particular session, it cannot be replayed somewhere else for another user. Then the second one is credential stuffing, brute force at login. Now, credential stuffing is when people bad actor continue to hit a particular endpoint with several connection or attempt or request. Now, how do you solve that problem? If you find that there is possibility during your threat modeling that there's possibility that happen, then you do rate limiting on all endpoint. Uniform login error, prevent enumeration. For instance, make sure that your error doesn't tell bad actors what they need to do to get into the system. And just give a generic, error messages. And bcrypt makes offline cracking expensive. Then you go to tampering with token claims. Now, any change invalidate the signature. Then you get error 401. That is user error. It's not a server error. So proving by test tampered, we'll see that later. Then repudiation, a caller denies making a request. Structured access log with a unique request ID, token carrier, and unique JTI. Now, when you have, these are security patterns and principles that you can put in place for a secure API platform. For example, it's just to give us an example of how to deal with a notorious, top 10 security concern that we call BOLA or IDOR. So now let's look at information disclosure, denial of service. Now, information disclosure, cross-tenant read, that is BOLA, the headline risk. Now, when tenant scope request, cross-tenant ID returns 404 error. Now, what does this mean? It means that if, for instance, I log in as John and I am able to access information that belongs to Kevin, that is information disclosure. I should only be able to access information that belongs to John, not the one that belongs to the other user or the other person. So that is where we have insecure, object reference. But this, what do? You make sure that the tenant is scoped, tenant scope query is used. Cross-tenant ID, when you try to guess the next ID of another tenant, then an error is returned. Okay, then you go to the next one. Secret token leaked via logs. Now, how do you overcome this? Redaction or redaction. Filter strips barrier tokens, password, and JWT shape blob at the login boundary. Now, this is what you do to make sure that those credentials and those secrets are not logged or they don't end up in your login system. So that shows that it must be scrubbed. It must be filtered away, in any log situation. So we have a request flooding, oversized payload. So per client, rate limiter returns 429 with retry after. Now, pedantic bonds every feed. This allows you to cap your size of your payload and to ensure that bad actors cannot flood that your endpoint. Then the response schema, user out has no hash feed. The contract cannot serialize. So you have to look at the contract of your API to make sure that it cannot be serialized. Then elevation of privilege. User performs an admin action, claims another tenant, require rules, admin. That shows that when you are writing your claim, your API claim, you must provide role claim. Whether admin this and that, you must provide that at data level. So why that is going on? So I want to say this, that this it's very important most important habit and discipline. A product security engineer who draws system first will find the flaws that lives between the boxes. So the ones a code scanner, which only see inside one box at a time, will always miss. So when you draw your flow, when you draw your system first, then you find the flaws. Then when you look at the flaw, you can validate that flaw by running them against threat modeling framework, then be able to record and deal with that from that point. So let's go to, we've identified trust case. Let's go to the next. Okay. So the threat model is the specification, not paperwork. So findings drive the design. So findings, password hash leaked plus offline cracking. Now, what do you design when you find that password hash can be leaked or is leaking and offline cracking is possible? Then what do you design for? You store bcrypt hashes. You store in bcrypt, never in plain text. Response schema, physically cannot serialize a hash. These are the design patterns you choose when you find out that particular threat. Then finding token forgery or replay or claim tampering. If you find that it's likely to happen, then what do? You validate signature. You make sure that your code, your design validates signature. Expiry, like expiration, the issuer, the audience, every information within your payload, JWT payload, should be verified the way it should. And this should be implemented at code level. Okay. Now, finding cross-tenant read. Now, what do? Enforce the tenant check at the data layer. I think I said it before. So when you find a particular vulnerability, let me say potential threat, when you are designing or you are drawing your system, the first what you do is that should drive your design approach. So yes, that should drive your design approach. So the reason why I am kind of particular about this is the fact that, let me just say this out here. AI is writing code at a velocity we've never seen. Some will tell you is times 10 or 10 times or what have you. But one thing I want to say is that the reality is that AI is amplifying what developers and engineers can do. And as that is going on, what I've discovered is that the most important thing now is for security engineers, product security engineers, to be part of representation, to be part of design. And you should be able to do your job in such a way that even when a proper design is done in a secure manner with a professional and experienced product security engineer in the room, and all the artifacts are produced, when you feed those artifacts into your LLMs, you will see that the LLM will have the right context and the right design to be able to produce for you secure code, secure designs, logic. Okay, let me put logic, and you have more secure environment. So it's more important now that AI is doing most of the job for us to do a proper system design, secure system design that will fit into the AI solutions or utilities that we use. So let's move to the next one. Okay, so let's look at our diagram here. So I have this diagram. So this is the first design. The first diagram was the one I used my hand to draw as a software engineer, as product security engineer. Now this is the one that I use the software to draw, because when I feed in the boundaries, my understanding of the system, this is what I got. So this is request lifecycle and trust boundary. So if you look at what we have here, you will see that we have security middleware. This is where rate limit is implemented. This is where security headers are checked. This is where request ID is logged. This is where the cross origin is kind of dealt with. And you can see the route, you can see the authentication dependencies, verify with JWT and stuff like that. Now, and you see where the data is. So if you look at the trust boundary 1 and 2, you will realize that data stored, tenant scoped, queries only. That shows that when a user is querying data at that particular level, it's scoped to the user. So if every information, your JWT information or session information is checked and it don't seem to have the right context or scope to access that data, you'll be denied. You have that error 404. It's a user error. So secure by default config production refuse to start with weak JWT secrets. These are the things I put down there for you to know what happened at B3. Like for instance, when you have the keys, you have the password, algorithm, and everything stored in those places. But the point, what I'm trying to make here is that this is how you make sure you secure the boundaries, and this is how it should look like. Okay. So if you look at my code, so this is very important. I don't know whether I can see that properly. So you can see that, but you should be able to see that. So if you look at Alice here, Alice is tenant. Alice had a valid token, but native code. If you look at it, Alice can have access. Look at the code base. Alice can have access to Bob information because that particular code does not scope Alice session or user information to our own data. But if you look at the other one, you will see that it's scoped to that data, to the Alice data, to Bob's data. So in the first one, Alice can log in, get to the data stage, and begin to use incremental, supply some IDs and get somebody else's data. But in this case, he can't, because if you look at it, you can see that the doc ID is scoped to the tenant ID. So, but in this case, it's not scoped to the tenant ID. So this is where, as a product security engineer, you have to understand how it works, the modules, and you'll be able to review. Even if you are writing, if you have an agent for code review, when you're building that agent, one of the things you do is to incorporate this kind of thing into the agent so that the agent will check for things like this. So the most common serious API bug, an authenticated caller reads someone else's object by guessing its ID. It's an authorization failure. So the fix is architectural. Put the check next to the data from the verified token. So Alice tried to access Bob's document using tenant B, you get an error 404. Blocked, and that is a correct implementation. So we have know where the control must live. Now, in my secure API platform that I'm using as an example here, this is my project directory or project structure. I have my app here. I have all the models, the services, for that API. Then I have a test suite here. I have some architectural document. I have some diagram. So this is how it works. But the point I'm trying to make here is that security engineer must know how project structure look like and must know where code, some maybe databases or databases are stored, code are stored, where the middleware applications, maybe your web servers, configurations are stored, maybe infrastructure, codes are stored, and be able to do the work that you're supposed to do around this infrastructure. So what you read for in review, is the tenant derived from the verified token, not a request parameter? Is every data query scoped by the tenant? Does a cross-tenant lookup fail? That's for that I explained before that. Are password bcrypt hashed and never serialized back? Are all JWT claims, as SIG, or they are expired, or they can verify the issuer or the audience? Can you validate all the attributes of the JWT that needed to be validated? So these are the questions you have to ask yourself, and you have to understand the project structure and what is in the project. For instance, I just put it here. I know it's very, but this is the code that implement just that. That says, okay, we have some functions here, some classes here that allows. So you have to know where they reside and be able to relate with this code to say, okay, this code is actually implementing that this particular, users are scoped to tenant, are scoped to their own resources. And JWT, we have roles, they have a authorization mechanism in place, by using maybe roles, and maybe we have 2 roles in that particular software and product. So you should be able to go through all this code and see that they actually implement them, and you can see the functions and the classes that make sure that all these things are done the right way. Then, so a control that isn't tested is a hope, not a guarantee. So what do? You test it. For instance, you have an idea of my system right now. My system is to ensure that IDOR or BOLA cannot be exploited. That bug should be locked down from design and architectural point of view. And that is what this particular project and this particular video centered around. But what I've done is to explain the concept around it and show you some of the snippets that I use in implementing this. Then the next thing is for me to show you how I tested for that, whether it actually do the work or not. So let's do that. Okay, so I want us to, so the last time I showed you my snippet on how you can test that identity, or let me say ID scope, the payload. So for instance, here I have my an API, I have my secure API that I put up here. So I want to kind of test it to see what we got. Okay, just make sure we, okay. So if you look at my API, I show you the snippet, the code base. I might kind of try to upload it in my GitHub account. So, but the point I'm trying to make here is that if you look at my output, it says both authenticated. It's okay. It says that tenant scope listing. So Alice, he sees one document from tenant A. Bob see another one document from tenant B. If you look at it here. Now, if Alice is trying to use HTTP method get to view the Bob's documentation or document, and it was blocked using error code 404. So, but when Alice was viewing her own document, it was 200. Okay. Then when she was viewing without token, it was blocked. When she was viewing with a tampered token, it was blocked. That is to show you that when you design for tampering, tamper-proof, repudiation, spoofing, everything that you identify as a threat factor, when you're doing your threat modeling, you design for them, you code for them, then eventually when you test for them, you get that result. And this is engineered into it from day one, not that maybe afterthought. So if, for instance, if I want to look at more something more important, maybe other way of looking into this. Let me use my UV server. Okay, so let me look at that. So if you look at my UV server here, it's starting. I can access it from here. Let me try to access it. Now, when I try to access, what do I get? I can't, because that endpoint is not routable for me. Now, if I change the endpoint to something like /docs, one sec, you might not be able to see that from your end, but don't worry. So I still have that. So let me change it to something that really work. Where are you? Okay, I have it here. So let me open it. So you see, I open it now. It says that if I hit that again, you see. So in as much as I'm visiting an endpoint that is routable, and I have and I can authenticate, then it keeps. But whenever I am trying to visit a particular endpoint that I am not scoped to, then I have that error 404. So that is just to tell you that designing, architecting, doing your threat modeling, and at the end of the day, coding for the right secure patterns and principles will eventually get you a well-secure product. And that is all. Because another thing I want to add at the end of this video is for product security engineer to know that with the way AI has amplified coding, democratized coding, the most important thing now is for security engineers to be able to understand design principles and patterns and be able to bring secure design processes into their workflows, into engineering workflows, so that the output of that particular workflow will be secured. The output of that agent coding your job and developing your features and checking in and making MR will be secured. So with that, I come to the end of today's video. Thank you, and see you in my next episode.